Okay, Wildcats. Today we're looking at Wednesday, April 3rd, solve exponential equations with graph and table. Page 56. If you would, update your table of contents. Okay, now your table of contents is updated. Let's take a look at our notes. Solving exponential equations with graphs and tables on page 56. A step to solve by graphing. Step 1, graph the right side. Step 2, graph the left side. Step 3, find the intersection. Okay, if you would, complete your notes. Now your notes completed, let's take a look at the examples. All right, which again are going to be on page 56. All right, solve each equation by graphing. Okay, now let's go ahead and do that with our calculator. So the first step is to graph the right side. So I'm going to go to on new document, no, add graph, and I'm going to type in 4, press enter, and I can see that I have a horizontal line at 1, 2, 3, 4. So I'm going to graph the right side in orange. So I have a horizontal line at 4. So 1, 2, 3, 4. Now, this has grid lines, so let's add grid lines. So menu, view, grid, line grid. Now, if you want your calculator screen to match what I have on the paper, we have to go to menu, window zoom, window settings. Now, see where it says X min? Well, that's this value. So X min is -10. X max is 10. They're counting by 1, so this will be 1. Now, the Y min, it looks like, is -1. The Y max, it looks like, is 12, and they're counting by ones. Okay, press enter. Now you have, and I'm going to darken the screen, I think, a little bit so you can see it. All right, it's a little hard to see, but we'll get through it. All right, now the next part, we're just going to graph the left side. We're going to graph in green. Okay, so we're going to press tab and graph 3 to the x plus, and I have to click to the right, plus 1. Okay, now I'm going to press Control T. Now this left column is the 4. When I click to the right, that's the 3x plus 1. So we're going to use these to graph our point. So I'm going to go, it looks like, I'm going to go all the way to -10 because that's where we start. Okay. Now, it looks like I can't graph that point. So I'm going to go until I can graph a point. Looks like 2. So when x is 0, I have a point at 2. So 0, 2. Okay. Let's see if I can brighten the screen up. There you go. Okay. Now, next point looks like is 1, 4. So 1, 1, 2, 3, 4. And then it looks like 2, 10. So 2, 10 is right here. And I believe the next point, that's too high. So now we have a point. We see from the graph that it curves like that. Okay. And we know from our previous lesson that plus 1 is our asymptote at 1. So we have an asymptote at 1. Y equals 1. Okay. So we have our curve is going to follow this asymptote and then go through the points. Okay. Now we can see that the intersection is 1, 4. Okay, and let's go up to the table. And you can see here that when x is 1, the y values are both 4. So your solution is the x value when the y value is the same, or the x value of the intersection. So your solution is x equals 1. Okay. All right, so now let's take a look at example 2. So we're going to graph the right side first. We're going to graph that in orange. So I'm going to go to on, new document, no, add graph. and then I'm going to type in 1, enter, menu, view, grid, line grid. Now, again, I want to make my window the same as the window on the paper, so I'm going to go to menu, window zoom, window settings. Now it looks like the X min is -10, X max is 10, so those are okay. The scale is 1. Y min looks like -1. Y max is 12 again, and scale is 1. All right, so now we have a horizontal at 1. Okay, now we're going to graph the left side in green. And playing with the light a little bit. The light's not great, but we'll just get through it. And see the lines right there. All right, now we're going to graph the left side. So press tab, and we're going to go forward to the X plus 1. Press enter. Now we're going to press Control T, and click to the right. These are the F4 to the X plus 1 values. Now I'm going to go to X is -10, because that's the farthest point in the graph. I can't graph those points. Now I'm going to go until I can graph a point. Looks like I can graph -1, 1. So -1, 1. Then it looks like 0, 4. 1, 2, 3, 4. And then 116 is, I can approximate that point right there. Okay. Now we know that the asymptote is 0 because there's no number plus or minus here. So we have a horizontal asymptote at 0. So we know our curve, based on the calculator graph, and from here, it curve falls along, the asymptote goes through those points. So here we can see that the intersection is at -1, 1. So let's look at the table. Well, we can see at -1, both values are 1. So the solution is the x value of the intersection of the x value in the table and the y value is the same. So the solution is x equals -1. All right, go ahead and finish up example 2. All right, now let's take a look at example 3. So we're going to go to on, new document, no, add graph. Now we're going to graph the right side, which is 1. So we know we have a horizontal line at 1. Okay. Now we're going to graph the left side in green. So we're going to press tab 2 to the X -1 -3. Menu, view, grid, line grid. Now I almost forgot we need to adjust the window so it matches what's on the paper. So we're going to go to menu, window zoom, window settings. X min is -10, X max is 10. Scale is 1. Y minimum, it looks like, is -5. Y max is 12, and the scale is 1. Okay. Now we're going to press Control T to find the points in the table. Now I'm going to go to X is -10. See, I want to make sure I can get every point on the graph. So I'm going to start here. Can't use that. Can't use that. Nope. Wait, yep. No, I don't want to use that -2.5. Let's use a better number. So we can use the graph to point 1, -2. So at 1, we have a point at -2. Okay. Now it looks like at when x is 2, we have a point at -1. So 2, -1. 3 is 1. So 3 is 1. 4 is 5. So 4, 1, 2, 3, 4, 5. And 1, 13, or 5, 13, which we can just put about right there. Okay. All right. Now we know the -3 is where our asymptote is. So we have a horizontal asymptote at -3. And our curve follows that asymptote through the points. Now our point of intersection looks like it's at 1, 2, 3, comma 1. And let's look at our table. Let's go when x is 3. We can see that they're both 1. So our solution is x equals 3. All right, let's take a look at example 4. So we're going to go to on, new document, no, add graph. So we're going to graph 11 first. Enter. We don't see the line because we need to adjust the window. So first menu, view, grid, line grid, and then menu, window zoom, window settings. So it looks like our x min is -10, x max is 10. Our scale is 1. Our y min it looks like is -1. Our y max is 12, and the scale is 1. Okay, now you can see your horizontal line at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have a horizontal line at 11. Remember, graphing the right side in orange. And we'll graph the left side in green. Now let's graph the left side. So tab 2 to the x plus 1, click to the right plus 3. Press Control T. Now I'm going to go to when x is -10. That point doesn't work, doesn't work. Getting closer. Our first point we can graph is -1, 4. So -1, 1, 2, 3, 4. Then our next point is 0, 5. 1, 7. So 1, 6, 7. 2, 11. And 3, 19, which is somewhere up there. Now, we have a horizontal line at asymptote at 3. So 1, 2, 3. Okay. Now we follow the curve onto the points. We can see our intersection is at 1, 2, comma 11. And if we can see in the table at 2, both values are 11. So our solution is x equals 2. All right, so go ahead and finish up example 4. All right, so let's move on to example 5 and 6. Now, just notice we need some notes for that, so let's go ahead and add that. So bring your notes back out. And then let's put here steps to solve with same base. Okay. So step 1, rewrite each side with same base. Okay, step 2, since the bases are the same, the exponents are equal. And then step 3, solve for x. Okay, so go ahead and finish up your notes. All right, now your notes are completed. Let's take a look at example 5 and 6. All right, so step 1, rewrite each with the same base. Well, you notice here in example 5, the bases are the same, so the exponents are equal. So you can say x minus 1x is equivalent to 1x minus 3. Okay. Now, the last step is to solve for x. We're going to subtract 8 from both sides. So now you're left with negative 1x equals 1x minus 12. We're going to subtract 1x from both sides. So negative 2x equals negative 12. Divide both sides by negative 2. So x equals 6. Okay? All right. Go ahead and finish up example 5. Now let's take a look at example 6. All right. Now example 6, the bases aren't the same. So you have to think about, well, what number can I raise to give us 8? Well, the answer to that is 2 to the third. 2 to the third power is 8. So we're going to rewrite 8 to the x as 2 to the 3x is equal to 2x plus 6. Now the bases are the same, so the exponents are equal. So 3x equals 1x plus 6. Now we're going to, last step, solve for x. We're going to subtract 1x from both sides. 2x equals 6. Divide 2 by both sides. So x equals 3. All right. Now, if that algebraic method was difficult, for example, 5 and 6, don't stress too much. In class, I'll show you how to use the calculator to solve for x using an example 5 and 6. So with that, go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.